Mr. Minnick here, explaining to his AP Java students how the comparable interface works, and specifically how the compare-to method works. We have a client program here with a main method, and I've instantiated two high school student objects, and you can scroll down to see the high school student class that I made up for this sample problem. There are three properties, three instance variables in this class: GPA, name, and height. And let's trace the code. Well, the program simply prints out one of these three system out print messages, and let's trace it. Student 1 is the implicit parameter, also known as the this object, and student 2 is passed in the parentheses as an actual parameter, and you might call that the explicit parameter, and they are passed down to the compare-to method in the high school student class. The this object, student 1 from up above, is being compared within the compare-to method with the student 2 that plugs in as the other formal parameter. And because it's coming in as an object, which we will study later in this course when we study inheritance, the object class, this is just the way a compare-to method must be implemented, with the data type object there and not high school student. And therefore we have to cast other to a high school student, and then with this extra annoying set of parentheses here, we access its GPA, which, even though it is another object, we do have access to its private instance variable myGPA, even though the this object's myGPA is referred to over here on this side of the greater than symbol. Well, let's check their GPAs to see which one is greater than the other. Because of this call statement here, student 1 has a GPA of 3.0 and student 2 has a GPA of 2.9. Therefore, you understand that this .myGPA is 3.0, and all of this over here simplifies to 2.9. Because this is true, that greater than that, we are returning 1, and the rest of this method is ignored. A 1 gets returned as the int, and that is a positive value, and because of that positive value, all of this, which simplifies to 1, is indeed greater than 0, and the program, when we execute it, should print out that Angie, or student 1, is greater than Bill, also thought of as student 2. Let's execute the program and see if that is true, that if Angie is greater than Bill. Yes, Angie is greater than Bill. Notice that I'm calling the toString methods. You could explicitly type toString and the program would still work fine. When you're in system out println and you have an object variable, the toString method executes by default. And I did provide an overridden toString method in this high school student class. So it's kind of nice that way. Okay, well, trust me that if we rearranged or changed these values up here, we could force the program to print Angie is less than Bill, or that Angie is equal to Bill, based on whether a positive number, a negative number, or in the case of the else clause, the number 0, is returned from this compare-to method. It's your job on the AP exam to be able to implement and write out the code that would be in the body of the compare-to method. Normally it's an if-else-if with a return 0 outside of everything. You could put an else there, but it's cleaner and safer, in my opinion, to put the return 0 there. This works nicely with the greater than and the less than. Let's pretend that we wanted to compare our two high school students by height and not by GPA, by height where that's an int instead of a double. Well, let's consider this one line of code and re-execute the program comparing Angie and Bill by height. Well, height is an int, not a double in this class. So we're really just taking the height of the one, the implicit object, and subtracting from that the height of the other one. Let's go check out the values. 56 minus 72 is negative 16. And because of that negative 16 that all of this simplifies to, the int that's returned is negative 16. So if I were to execute this program right now, all of this simplifies to negative 16, which is not greater than 0. So that becomes false, and it trickles down to the else if, where negative 16 again is indeed true, less than 0, less than 0. So this would execute, and it would say that Angie is less than Bill instead of Angie is greater than Bill. Let's check. Run the program. It should say that Angie is less than Bill. Now we're now comparing by how many inches of height Angie and Bill have, and not by their GPAs. Let's check it out. Yep, Angie is less than Bill according to the output. So while she's got a better GPA, 3.0 versus 2.9, if you compare them by height, she's less than. So it all depends on how you, the developer of the high school student class, chooses to code and implement your compare to method. You could compare by GPA, or you could compare by height. Now we could have changed my GPA and all 4 of these occurrences to my height, and this program would have worked with that if-else-if statement. I just wanted to show you how you could, if you have an int, compact it all on one line. You cannot put my GPA in there. If you did my GPA in both of these spots, trying to consolidate the if-else-if return 0 here to one line of code, this would be a double, and you're forced by the universally agreed upon comparable compared to abstract method to return an int. And this would be a double, and even if it is 18.0 compared to 18 or some other number 0.0, you would probably get compile errors or warnings. Perhaps you could cast and solve the problem, but I'm not going to discuss that. I would just write this version with my GPA in there as the most elegant answer. Putting this back the way it was, I don't want to mess it up. It had to be my height there in that variation. One last alteration to this version of the compare to method would be to use this last line of code as the single line in compare to. This return statement compares the two high school student objects by name. And you know that you cannot compare strings with greater than and less than inequality symbols. And you certainly can't take one string minus another string. So check this out. Since the string class also implements comparable, and therefore the string class has a compare to method that we've studied earlier this year, and you could read about it in the quick reference API cheat sheet, the compare to method in the string class can hook together a string variable with a string in the parentheses, and because of my notation, this works. And we're comparing two strings using the compare to method of the string class within the compare to method that we're typing out and implementing of the high school student class. That's pretty interesting, and it works. Let's run the program and see if Angie is less than Bill alphabetically. And yes, Angie is still less than Bill because the A has a Unicode value that's less than the B. Specifically, 65 is less than 66. Okay, so that's our discussion of high school student. Now let's check out elementary student. Elementary school students, this is a work ethic. 100 for Colleen and 12 for David. We don't give grades in our elementary school. We just give work ethics. So, which one is greater than the other? Well, obviously by inspection, 100 is greater than 12. And because student 3 is the implicit parameter here, 100 is indeed greater than 12, and therefore this should be true. And some true number should be returned by compare to, causing this if statement to be true and causing this to execute and not the other two system outprints. Well, we see down in the output that is what happens. Colleen, she's greater than David because we were comparing by at work ethic. Well, let's check it out to verify that. I'm scrolling down to the elementary school student class and looking at the compare to method there. And without using a large if else kind of structure, I did write this as one line of code. Since work ethic is an int, you can get away with the subtraction, and you're guaranteed an int as a return value, and therefore it works beautifully. I'll leave it to you as an exercise to test this out with a comparison of strings, their names, that is, and you would essentially use the same line of code that we used up in the high school student class. Okay, I will point out that throughout this demo, anytime that you saw this as the reference to the implicit parameter, it was optional. You don't need this dot myGPA. You could just consolidate that. You don't get any extra credit for knowing that. It's fine if you type this dot to be careful, but you don't need this dot in any of these examples that were in this file. Okay, I believe that's it. Copy and paste this. I did put 3 classes in the same Java source file just for convenience. Normally these would be 3 separate files. I took off the word public from the class header here for high school student and for elementary student because that's the rule. You can only have one public class in a Java file, in which case this one's named ComparableDemo1. Thank you.